And here we are back again, everyone. Time for another tutoring video. So this one, as I promised, is the second half, looking at specifically questions from the last couple of assessments for not just pre-cal, but we got AP Stats now joining in the crowd. So let's go ahead and let's look at these questions. So this is from the last formative assessment. This was 2C that we're going to look at specifically. So we're going to answer this question. So we were given the following two functions, and we were asked to find g of 86. So remember, pre-cal, that when we see this open dot, that means we are doing a composition, not a multiplication. I saw way too many people doing this as if we were multiplying the two functions together. So I saw a lot of people doing this. That is wrong. This means g of x. So let's walk through it. We're going to be plugging in, we see is 86. So what we're answering is g of 86. So we'll start with this inner function right here. We'll take that 86 and plug it into our g of t. So this is going to be square root of 86 minus 5. So you see I'm just addressing is the inner function. And that is in this part right here. So 86 minus 5, we know that's going to be 81. And hopefully, without the calculator, you guys know square root of 81 is 9. So there's that first part done. Now I got to figure out, hey, what's g of 9? So now once again, I go back to my g function, and this time we're going to be plugging in 9 for t. So 9 minus 5 is square root of 4, which is 2. That is my answer for this one. So composition, we are not multiplying here, okay? This is different from what we saw with the addition one. Okay, so I think most people got this one right, but they kind of waffed on A and C because they were trying to do it like part B. So B, yes, is g of 9 plus f of 9, because that's what we do with addition, subtraction, multiplication, division. But compositions, remember, were different. It's one function going inside of the other. So no multiplying here. Okay, so hopefully that clears up the question on number 2 from the last formative assessment. All right, AP Stats, I know you're itching for this one, so let's go ahead and let's look at yours. So let's scroll down. So specifically looking at the short response questions. So looking at number 6 and number 7. All right, so number 6, we were given this dot plot. So it says we have a dot plot of voter turnout for the 50 states, plus the District of Columbia in a recent presidential election. So it says to describe the distribution above. Whenever we hear the term describe the distribution, that means time to take out your socks. I don't care if they're old and they're smelly. It's time to use socks. Okay, so shape, outlier, center, and spread. So again, doesn't matter what order you address it in, but you need to address these 4 things. Okay, I am giving you the AP recipe. Okay, this is Colonel Sanders giving you the original recipe for Kentucky Fried Chicken. I'm giving you the recipe on how to describe the distribution. Don't mess it up. Okay, socks. Okay, shape, outlier, center, spread. I got to talk about those 4 things. That's why this question was, guess what? 4 points. So if you lost a point, you probably didn't address one of these things. Okay, so shape. Okay, I heard a lot of different terms for shape here. Okay, but you got to justify it. So make sure. So like when I look at this, yeah, some of you said like multimodal because you kind of literally like traced out the curve and you were like, oh, but there's a lump here and there's a lump here, there's a lump here. Try not to be so super specific. Just look as an overall trend. So if you look overall at this, it kind of just has this like one lump and then kind of trails off down here. Okay, so I would say more this is unimodal. And for this one, it would have been acceptable just because of the way the distribution shaped out. I did accept people saying that there was a left skew. It's a slight left skew. So I'm going to put here slight left skew. Also, what would have been acceptable is if you would have said then roughly symmetrical. So either of these, so this or this. Okay. Now, this is where this is describing all four of these linked together in some way, shape, or form. Okay, these four kind of descriptors. If you're going to say that there's a slight left skew, then you better say under outliers. Yeah, there's a potential outlier. This might be a potential outlier. So I'm going to say a potential outlier to the left at around, and I'm going to grab that number. So like around 47. Okay, be specific. You're describing the distribution. Okay, you don't have to go super specific, but some specificity. Okay, so potential outlier at around the left of 47. If you're saying it's roughly symmetric, then you might say, I don't really see any obvious outliers, but you mentioned the outliers. You can't just not say it. If there's no outliers, you got to say there's no outliers. Okay, don't leave it blank. Center. Okay, so where do I see the center of the where do I see the most points kind of gathered? Okay, I kind of see it around here. So I would say, so again, since I'm not calculating anything, okay, I'm not going to say, oh, the mean. All right, you can say mode, because, okay, I see the most amount of points is around this 62 or 63. So about 62, 63. So I can say the mode is around 62 to 63. You can also say the median. Since we do have a dot plot, you can literally go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, because it's 50 states plus the District of Columbia. So 26, that would be my middle score. Okay, so we see we're going to be somewhere around here, like we said, around that 62, 63 mark. That's where like the median would be. So you can kind of also say the same thing for the median. Okay, but we want to say a measurement of center. Okay, or where we see the massive distribution. So I can say it looks like the distribution is centered around, and say a number. Okay, don't just say I see a center mass. Great, that's really not describing anything for me. That's just like here, we're kind of, by the time you get to here, you're kind of now refining this description of, if you said it's unimodal, great, where's the lump? Where are you telling me that lump is? If you're going to say it's bimodal, then you better start telling, where are the two lumps? What's the number? Be descriptive. Okay, finally, spread. Okay, so now here's why I was a little bit lenient, because I did not really get into that much detail with you with regards to spread. But when you say spread, just like with center, you want to give an actual measurement. Okay, so remember that when you calculate range, and I'm going to put it over here. So remember, range is not you saying from this number to this number. Range is a subtraction. It is the max minus the min. That's what range is. Range is not saying from min to max. That is not range. So get that out of your head. Range is you calculate a distance from the highest point to the lowest point. So in this case here, if you said 71 to, let's say, 47, then I would have said from 71 to 47, figure that out. So this comes out to be 24. That's my range. Range is not, oh, from 71 to 47. No, that is not range. You can have also talked about the interquartile range. That is also an acceptable measure of spread. Okay, so however, here again, I don't have the specific numbers, so this is going to be more work to do. So this is where you have the freedom based on the information given to you on how to describe it. Some will be less work, some will be more work. So it's up to you. If you want to do interquartile range as your measure of spread, guess what? This is going to be a lot harder to do with this data. If I had the individual numbers, maybe if this were a stem and leaf plot, okay, IQR would be acceptable. It's not that hard. But in this case here, it's going to be a little bit more work. It's probably just easier if I just kind of grab the range and talk about it that way. And then I could say, based on what I'm seeing here, it looks like the data is fairly spread. So I could say fairly spread out with a range of about 24. Okay, standard deviation here would be the worst measurement to use. Standard deviation is another acceptable number to use for a measurement of spread, but again, since I don't have specific numbers, I really don't want to be using standard deviation because that's going to be a real glut of work to do. So again, describing distribution, socks, SOCS, socks. Put on your socks, whether they're smelly or they got a hole in them, put them on when you're describing a distribution. All right, let's go to number 7. All right, so this time we have a stem and leaf plot given to us. It is describing the distribution of ages in the years of 20 participants at a family reunion. Are there any outliers present? Justify your answers. So I saw a lot of people, which was great, start by doing the 5-point summary. Awesome, that is work. You gotta, that part goes to part of your justification. Okay, so 5-point summary. So min Q1, median Q3, and then max. All right, so let me see, I think I have the numbers here. No, I do not, so I'm gonna have to recalculate that. So I'm gonna go off here to the side for a moment and get those numbers, and I will be right back. So we're gonna take a little time skip as I do that. And I'm back with the numbers. Boy, I work really fast, especially when we time travel. So here we go. So I got min was 7, Q1 was 12.5, median was 24.5, Q3 was 48.5, and max was 91. Okay, so there's my 5-point summary. So I have to talk about, are there any outliers present? So remember, that's going to be using that 1.5 times IQR, and we're going to either add that to Q3 to get our upper boundary, or we're going to take Q1 and subtract it from that boundary. And if any values go beyond those two extremes, that's an outlier. So if we're less than this or greater than this, then we got, an outlier. All right, so let's figure this out. All right, so IQR, so Q3 minus Q1, so 48 minus 12, so that gives me 36. So 36 times 1.5, so that gives me 54. So I'm gonna take, so if I am less than 12.5 minus 54, or I'm greater than 48.5 plus 54, I got an outlier. So 12.5 minus 54, so that's a negative 41.5. So I'm pretty sure nobody's going to be an outlier on the low end. We would literally have to go backwards in time into the quantum realm here to get somebody who has a negative age. Now on the other end of the scale, 48.5 plus 54, they'd have to be a centenarian to be considered an outlier. So our 91, even though it's out here and does cause a bit of a right skew in the data if I'm looking at it sideways, so if I turn my head clockwise 90 degrees, I kind of see like this skew to the data. Even with that point, even though it seems like an outlier, it technically is not an outlier. So I would say no outliers present. So my justification would be this. So now, some of you did this and did not give me a conclusion. This was worth 2 points. So if you did this, awesome, you got a point for your work. But you didn't come up with a conclusion. Was there outliers present or not? You just kind of had these numbers and go, there. And I'm left going, there what? Great, you got these numbers. What does that mean? So you have to follow it up. So even if you wrote this is still not the 2 points. There's one last part that's missing, and then you have to make a concluding statement. There's no outliers present because no value is less than negative 41.5 or greater than 102.5. That's it. So you got to show this to show where in the hell did you get these numbers, and then you have to make your conclusion. That's the 2 points. So if you missed a point, it's probably because you were missing one of those two things. Okay. Part B. Now, what would be a better measure of center for this data, the mean or the median? So I just stated here earlier, there is a right skew to this data. Okay, so the median, because there's a presence of skew, the median would be a better measure of center. Justify your answer using the data. So it would be a better measure of center because the data presents. So you can talk about it a couple different ways. So the data presents a right skew. Now what? So what? What do I have to worry about with a right skew? Remember, what does the skew do to the mean? It would pull the mean further away from the center and now not be where the center mass is. So I'm going to explain that. So pulling the mean towards the right, which in this case, and again, we just finished. So if you got this 5-point summary, guess what? Part of that 5-point summary, because you did your 1 var statistics, part of that 1-point summary, you already calculated the mean. So why don't you go ahead and use it? So from the stats, and let me pull up my stats because I had already done it earlier. The mean was a 32.65. So look at where that would put the mean. 32.65 would put it somewhere here. Your median is a 24.5. That would put it here. You see how the 24.5 makes more sense than using the 32? That's what I'm talking about. You gotta be specific. Evidence. Okay? So we're going to court. When I ask you to justify the answer, you gotta point to the numbers. That's why it's gonna say use the data set. Okay? Because if I don't mention numbers, if I don't mention the shape, you're just vomiting out to me, and I like to use that term to kind of illustrate the point. You're just kind of regurgitating the definition. Like I could close my eyes, not stare at that data set and go, median, why? Because there's a skew. Why? Skews mess up the mean. See how that's like not specific? That's not at all in the context of this question. Give me specifics. You're right. Your definition is totally right. But how does it connect to the numbers. Bring the numbers in. Point to it as evidence to show, you see? This is what I'm talking about. The mean is at 32.65, while the median is at 24.5. That's a better measure, or closer to that center mass, than a 32.65. 32.65 is not even any point on the data set. Well, I mean, neither is 24.5, but 24.5, well, at least I'm surrounded by numbers. Here I got from 29 to 39. This 32 is like nowhere in the vicinity of at least being close to a number than that 24.5. So this is worth 2 points as well. So 1 point for identifying, okay, the median would be a better measure of center, and why, with the justification of using the numbers. All right, so hopefully this was helpful. Again, as always, the conclusion of all my videos, if you like them, please hit the like button. Let me know. Let me feel the love out there from all of you watching this. And if it's going out into the ether, well, hopefully some ghosts will give me some love and hit the like button at the bottom. You know, and if you like the channel, hit subscribe as well. And I will see you guys on the next tutoring video.